So I'm speaking about on-chain RL, AI agents. I believe there are many AI agent projects that we're seeing everywhere, right? So we're gonna discuss a little bit about this information about agentic RL, which is agentic reinforcement learning. So going first, let me just introduce about Taurus AI. We are at the singularity point about Solana and AI. So we're really focused on Solana. I believe we have seen a lot of amazing projects in Solana ecosystem in terms of AI. And of course, this started because of OpenAI, right? A few years back again, we've seen a lot of AI tools coming in because of OpenAI. They launched the first LLM. They started from GPT-2 up to what we have right now. And we've seen a lot of like traction in terms of the users and many more. And they basically make everything easy for all of us. Basically, like the Vive coding applications, all of it are becoming more easy for all developers, whether non-technical and so on. So yeah, and also we've seen about Solana's adoption, where there's a low barrier and of course massive growth in adoption, where every year we've seen a lot of millions of tokens created in 1 year, and of course millions of active addresses, new active addresses, and of course the meme mania. Of course, I don't know if you guys have seen that before. There was a lot of meme coins launched before as well, and a few months ago. And of course, you're one of the grant recipient of Solana Foundation. So we've been focusing on building AI infrastructure, where we also have our LLM as well. We fine-tuned it specifically for Solana ecosystem, and more products that we've involved as well. And of course, we also have our marketplace, and we're working on improving more products, extending it beyond as well. So, of course, these are architecture. We are focused on four things, which is framework layer, application layer, and aggregation and verification. But before anything else, I'm going to share more about the frameworks. I don't know if you're familiar with some of them, but I believe Lisa and Rig is also one of the popular frameworks in terms of agentic. And of course, the Solana agent, if you have seen it, use it before, you can try it if you haven't as well. But we also have our TGPD. We've also trained this. I'm not sure if I can show it, but if not, maybe we can focus on another one. So I've seen a lot of like agent projects, right? And we see that LLM RL and agentic RL are two different things, okay? Why? Because agentic RL is focused on not just generating outputs. It's more focused on reasoning, right? And I've seen a lot of like vibe coding apps. If you notice, one thing makes more different about this, it's because they have what we call self-reflection and self-improvement capability. Which means that if they see your code base and there's something wrong within your code base, it will try to self-reflect and make actions based on it. So there are many things here. Let's not talk about the technical part, but we've seen a lot of like features coming in ChatGPT, other applications, and majority of it is really more into how we can improve the reasoning models, right? And actually, we're gonna extend that further here. So I'm just gonna show you a bit about our RL agent architecture, wherein we have this major features where the reasoning, planning, memory, perception, and tool use. So I think we usually don't notice this, but the agents that we're interacting with are quite more improving in terms of reasoning, because not just the memory is working, like the long and short memory, but they can also plan in more extensive. So the thing here is that the memory is also either structured or unstructured. The perception could either be multimodal, which means that it could be either a text, an image, or a video, audio. And of course, there is what we call the last part. So the agents right now, if you've seen some of the projects, they are extending it further with this what we call self-improvement, which means that it could be either like the reasoning, even if another one is also, I don't know if anyone here is using Vive coding apps. Yeah. Yeah, so we're basically using it, and something that we find very interesting here is that you're getting better every single day about the languages that we're going to be using, exploring. And also, in terms of this, we can see that by the concept of reinforcement learning, we're adding what we call the reward system. So, which is a very interesting part because the agent, whenever they make mistakes, he had to be given a reward if they actually get a good results. So basically, for example, every time we interact with LLMs, right, or AI tools, whenever they answered us incorrect output, we usually say something, whether like try to generate an answer again or try to do it again. But this time, because of RL agent architecture, they can basically know what the problem is already without us telling them. So next here is we see the environment. Of course, environment could either be here, all of these things, right? It could be either a web, a code base, a robot, or somewhere, anything, anywhere. Okay. So these are the concept. The one thing that makes it very different is the reward system. So it doesn't mean like you have to give it money for it to correct. It's not like that, right? Reinforcement learning is more of like self-understanding, okay? It's not scary, okay? It's just making it more aware of the mistakes, the failures, and any and so on. And of course, the RL agent architecture, they could either be different things, right? We can see here the RAG. I'm not sure if some of you are familiar with retrieval augmented generation. It's where people use for domain-focused data. So if you're building a medical-focused agent, you should use the RAG as well for your memories as well. And also we have the RL for internalized long thinking. It could be either using different models that you've been using, whether it's DeepSeek, and these of all of this as well. And of course, there are many more. So it's extended beyond. But the thing here is you've seen the word self, right? So the more that we see that, it's becoming more aware of its, some mistakes, right? Because usually before, I've encountered a lot of problems in terms of using AI in coding. So sometimes I notice like it takes so many times for me to give a better context, or it's like a iteration of like step by step. And usually it takes a while. Like before I can just debug code easily, but now that with AI agents, it's getting more difficult. But with the self-reflection capability of reinforcement learning, and it goes deeper about that. So that's basically all of this. We can, if you wanted to learn more about, reinforcement learning, you can try to, search about it. You've seen a lot of like applications to anywhere you're using right now. Yeah. So another one I wanted to highlight first before we go into how we can on-chain it. So what anxiety of your agent could either be from here. So I'm sorry for showing some like code bases here, but basically here you have a task description. So it's like how you command your agent to do something for you. It could either be trying to improve the code base, and then from here you actually show a context of what those files would be. So here we've seen like the workspace of everything about the train.py, which is the training part of the script as well, and then also to evaluate the performance. And then lastly here, we've seen the visualization of how the agent will actually learn from here. So with the agentic RL, it's always gonna be more aware now to see what the problem would be in terms of the train.py that we're seeing here. So another one is here. So in the context of agentic, this is what we see at the back. So we're just showing what it looks like. So this is more of like the prompt, right? The prompt part. So what you're seeing here is the context of the system prompt. So even when you're using vibe coding apps such as Cursor, Windsurf, and many other applications, this is what you're gonna see. You have a context of what the agent will do. And of course, you have here the information, like giving them the actions to do. And from there, we see the observation, each of the actions that the agent is doing. So basically, every time that you ask them to do like changes, for example, create me a presentation. So every action that they actually do from there, it's going to give you observation. So they're going to tell you that, okay, this slide here has a little bit mistakes. So I try to improve it and then go into the next step and so on. So RL is more, focused on that as well. And here the responses, and of course how it looks like in terms of the performance of the agent itself. So this is a little bit long, but like the highlight here is that for you to get a better results of your AI agents, make a better system prompt and try to give more context. And whenever you use AI coding apps or applications, try to be very specific. Okay. Next, we go here. So this is the high level that I showed a while ago. So basically, that's your task description, and then you have a prompt, right? In terms of your prompt, it could either be a simple prompt, it could either be a chain of thought, it could be either be a zero shot, or just a straight line of specific instruction. And then here, the agent will save it to the memory. So every time you use ChatGPT, right, you notice that when you ask them, what was our previous discussion? It will try to retrieve all the memory regarding of that conversation, and it will going to use that for the next action. So here, we're seeing a lot of things, but that's the highlight, okay? Next here, the environment could either be a code base, it could either be a Canva, a Figma, or anywhere that you put the agent would be. Or in the terms of the centralized application, you could put it into the centralized exchange. So the environment is similar to that, right? And of course, here is the output for that. Next would be is this as well. This is just more of an example so that you get kind of like familiar about how does it really works. So basically, that's the initial memory. So the same way as how we think about things, we have a working memory where we use it a lot. Then we also have a memory where we delete it afterwards because it's not useful or not something we need to use afterwards. So similarly, agents have to do that as well. So every time that they actually save a memory, then try to reuse that, see if there's anything that they can actually use for their next actions. So here, the response from the agent and then from the assistant as well. And then of course, they will execute the action whether it's correct or incorrect as well. So as you can see, this is more of like a coding kind of like environment, but you can extend this further whenever you put this in the application as well. Next as well, the reflection part. I know that we've mentioning this a lot, but honestly, every time I see about agents, I usually look at their history of how they process their thoughts, because sometimes you kind of see where the hallucination came from. So I think I've seen a lot of like amazing projects where they really show to people how their agent is thinking. So I know you guys know some of it, but this is basically how it looks like. So they have this what we call reflection, plan, and observation. So these are the three things that the agent will do at the back as well. So basically, they try to observe something else or anything at the moment and try to reflect something about it. Like, is there any mistakes or is there anything that needs to be improved about it? Or if you ask them to analyze the sentiment from community, so now it will try to reflect what they can do better. And then the planning stage will comes in. So basically the agent is more now reflecting, not just you asking every single thing from, trying to feed it every single time. So yeah, that's the high level. So you can take a screenshot of it or a photo as well. But basically, we can view this as well. So you can think of agents as somehow like us connecting with other people. So basically, we can either adapt to each other's languages, physical gestures, and many other things. And similarly with agents, we can simulate that, especially if you're building a multi-agentic applications. So you either have a persona of each of these agents, and of course they have a certain task that they're doing, and so you can see how these agents can actually do specific tasks like this. So these are like one example of conversation. Maybe you can think of it as like a Sims. I'm not sure if that's the right term, but this is basically how I see it. Agents can actually communicate to each other so that they can actually collaborate on doing the task. For example, if you're asking them to create a presentation, there may be an agent searching for the references. There may be an agent trying to create the figures or the numbers. So it's more of like collaboratively the agents work together so that the output is going to be great as well. So yeah, so that's how things are. And in terms of reinforcement, they can actually reward each other in terms of how they do well, or maybe you can also set that reward system for them as well. So yeah, that's why in connection to the centralized applications, we're talking about a lot of that. We can see the concept of self-governing AI agents. I believe this is going to be the next part in terms of how AI agents are going to be improved in a bit, in a few months after as well, where they're going to be more on, they can manage assets and contracts. Hopefully we can see more amazing projects around this as well. And of course, the transparent actions where, of course, in the blockchain ecosystem. And of course, we've seen that some of the agents nowadays, they can actually negotiate, pay and adapt to different markets as well in a centralized application. So I've seen a lot of the exchange as well that are really incorporating it, which is a very interesting see the progress as well that we have in terms of this. So we can see this. We can see many things that the agents can do more. These are just a few things, but I believe we can see more use cases around self-governing AI agents, hopefully. And then also, I know some of us may be a trader or a builder anywhere where we can put AI agents in our applications. And of course, these are just some of the papers. So sorry for that. But I've seen here the MCP. Maybe like you have a project that you're working on and you're building MCPs. This is a good project from Anthropic that they make everything easy for people to integrate the agents anywhere, regardless of yeah. So that's one. And of course, these are just some examples that I believe we can see with it. I guess the context here is that we can see agents becoming more self-context aware, and they self-reflect much better than before. So I can ask for anything under the sun, and then it tries to do the searching and everything else for me, and just verify it for as well. And of course, lastly here is the framework for language agents. I just wanted to highlight that in terms of building agents, there's a lot of iterative process. There's a lot of feedback because agents could either fail at some tasks, so you have to really guide them well through either context training or fine tuning in a lot of these, or more specifically the prompt engineering side of it, where we can continuously help them to be better in terms of responding to queries, the answers from the users, and many more. So yes, the environment could either be your databases or somewhere like an application or a web or an API. So right now we're seeing a lot of APIs available to build it as well. And yeah, so we're kind of building this as well for, I'm not sure why I kind of show some video here. Okay, but anyways, so yeah, that's another product that we're building right now. It's the AI dollar. But if you wanted to know more about it, you can follow us on X as well. And of course, yeah, that's pretty much with my presentation. And thank you so much for listening as well.